I am on page 206, and we're looking at the Lesson 6.3 review. Starting with vocabulary. Fill in each blank with a word from the list below. A or an blank is the y-coordinate of a point where a graph crosses the y-axis. That is the y-intercept. A or an is the y-coordinate of any point that is the highest or lowest point for some section of a graph. That is relative, max or min. Maximum if it's a hill, minimum if it's a valley. A or an is the x-coordinate of a point where a graph crosses the x-axis. If it's crossing the axis, that is an intercept. A figure has blank if there is a line that divides the figure into two halves that are mirror images of each other. That is called line symmetry. Blank describes the appearance of a graph as it extends in both directions away from zero. That is the end behavior. And a figure has blank if it can be rotated less than 360 degrees around a point to coincide with itself. This is from that video from YouTube that I showed you. I couldn't demonstrate this one to you. But that is rotational symmetry. If you didn't watch those videos, I strongly encourage you to go back and watch them. They're written for middle school or high school kids, so they're not completely off-the-wall complicated. I thought they were pretty easy to understand, well, relatively easy to understand, but they're much better than I can explain. Skill review. Read each problem and complete the task. Explain how you can use key features to identify the correct graph. And they've given me equations there, or an equation. So the equation is 2x plus 2y is 6. Now be careful. It's very tempting to say, oh, that has a positive 2 slope. But remember, this is written in standard form. So we need to get it in slope-intercept form, and then we can make a decision about the slope. So y equals mx plus b. We need to move the 2x. Now, as soon as I did that, I ended up with a negative slope. So just by getting it in the proper form, things changed. Divide by 2. So y is negative 1x plus 3. So I am looking for something with a negative slope. And wouldn't you know it, they all have a negative slope. But we can also tell about the graph because we know that slope is negative 1 over 1. And the y-intercept is 0, 3. So using that information, I can find the graph we're looking for. I'm going to start with the intercept. Which one or ones of these has a 0, 3 intercept? Well, this one does. This one has a 0, 6 intercept, 0, 6 intercept, and 0, 2 intercept. So just on the basis of the intercept, I can tell you that the graph I'm looking for is A. That's the one that matches the conditions that we have. Okay, number 2, they want us to sketch a line with the following key features. So let me make a copy of these conditions. I should have already done this, but I didn't realize I was going to need to. And bring it back to my notebook, which is right here. And let's go ahead and put down those conditions and sketch a graph. So let me draw a coordinate plane. Does it give a y-intercept is -9? The maximum is 16. Oh boy. So this graph's going to need to be pretty big. Let me resize this just a hair and we'll draw the graph. So I'm going to draw a pretty good size graph this time. I'm going to go at least in the y direction. Heavens to Betsy, that was horrible. And that's even worse. There we go. All right. So the first condition says the x-intercepts are -3, -1, -3, -1, so back 1, back 3, over 1, and over 3. So it's looking like we've got some symmetry maybe happening here. I don't know yet. We're not there. The x-intercepts. The y-intercept is -9. So I'm going to go down here to -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And plop that down. And you may be thinking, well, how do you know that it's not over here? Because it said the intercept. That means it's touching the y-axis. It's not a minimum, or it could be a minimum, but it's actually on the axis if it's an intercept. There is one relative minimum, -9, and it occurs at one point. So this is the relative minimum. This is the lowest that this graph will go. There is a relative maximum, 16. It occurs at 2 points. Okay, so let's go ahead and mark. There's 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So let me extend this just a bit to meet that requirement. Now, it doesn't say it's an intercept. It just says it's a maximum, and it occurs at 2 points. The graph extends down indefinitely in both directions, and the graph is symmetrical about the y-axis. So here's what I needed to know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sorry, it needs to go over one more. And then the same on this side because it's symmetrical around the y-axis. And here comes the graph. Oh boy. I've got to freehand this one. So it's going to come up here. Let me try to get it as large as I can. All right, so here we go. It's going to rise to the maximum, and then it's going to fall through the axis down to the minimum, back through that point to the maximum, and down again. This is looking like maybe it would be a periodic graph if it continued. It extends downward endlessly in both directions. So let's check the conditions. The x-intercepts are -3, -1, 1, and 3. The y-intercept is -9. There is one relative minimum, -9, that occurs only at one point. So there's one valley. There is one relative maximum, 16, but it occurs at 2 points. So you have 2 hills. The graph extends down indefinitely in both directions. That's end behavior. And the graph is symmetrical about the y-axis. So that's pitiful, but that's the picture that we're looking at. And that is the end of page 206. So I will meet you back for page 207.